So when you're thinking about finding the surface area, right, of a three-dimensional figure turned two-dimensional into a net, we sort of unfold it. It doesn't matter what shape necessarily that figure is, the process will be very similar. So in this case, we're working with more of rectangular or cube type shapes. And now you'll see we have a fun shape added in. We've got our triangle. So we're going to do the same thing. We're going to take our three-dimensional figure and we're going to flatten it out into a two-dimensional net, find the area of those composite shapes, and then put them back together in order to find the surface area, right? We'll add up all of those mini areas to find the total surface area. So when we think here, if we kind of look at this base, we can see that this base here whoop, um, can kind of correspond to this base here. And so when we do that, we can see that we have a width here of 5 inches, right? This is given to us. And then we're given some other information. So we're given that this up top, up here, is 9 inches. And we're given that this height here is 4.3 inches. Okay, so when we think about that and what that means, we know that this length corresponds to this length, right? Those are the same length because it closes, the figure closes. If it were a different length, there would be a gap, right? There would be a little hole, but there's not. So we know that this length here is 9 inches. So the area, when we multiply them together, 9 times 5 gets us 45 inches squared. Well, the good news here is that we know that that is the same size for all three of these rectangles, right? They're all 5 inches by 9 inches, right? Because this is an equilateral triangle. We're given that this and this and this are all the same width. So we know that this is also a 5 and this is also a 9. So this also has an area of 45. And simultaneously, this side here, the final face, if we call it purple, also has a 9 by 5 or area of 45. So then finally, we get to dive into these triangular faces. And we know that the base, right, or one side length is 5. Well, it's given to us that they're equilateral. We know all of the sides are going to be the same length. But when we find the area of a triangle, we don't really want to multiply a side by a side. We want to know what the height of that triangle is. And we're given that that is 4.3. So when we multiply 5 by 4.3 and then divide it in half, right? So you don't find the area of the whole rectangle around it, but you find the area of that triangle, we get 10.75. And these triangles are the same size. So we know that both of them will have a 10.75 square inch area. So if we clean that up a bit, there we go. We can see that the next step, right, is to take all of those mini parts, right, those composite figures, the rectangles and triangles within, add them all up. So 45 plus 45 plus 45, and then two 10.5s. So we have 45, 45, 45, and two 10.5s will get us the surface area. And when you find the sum or you add them all together, you end up with surface area of 1,565 inches squared, two-dimensional.